So in the second one, we're going to talk about how we can fill electron configurations for some of the more complicated species, things like transition metals and below. And so it's going to be the same ideas of the Aufbau principle, Pauli exclusion, and Hund's rule that we talked about in the last video, which I'm assuming you've already watched. But here we're just going to look at a few things that get a little trickier. The first thing that makes life a little harder in this case is the filling order. As we talked about in the main lecture, it gets a little harder to figure out which electron orbits get filled first. So there's this little trick, though, for determining the order that you can do. I'm not going to draw out the whole thing, but I'm just going to show the basic ideas here. And that is, you can write out your orbitals like this, where I have the S's, P's, and D's, and F's all in nice columns. And to figure out the filling order, I can go 1, 2, 3. I can do these diagonal lines through here. So I guess I need the 5s to come there, and so on. And so you can figure out which orbits get filled first. For example, we fill the 1s, the 2s, the 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, etc. The second thing that makes these ones trickier is that you have lots of special cases. And so in the main lecture, we talked about some of these in the transition metal. But for example, if you look at titanium, which has an argon core, it has 4 valence electrons. So E- is electrons plus an argon core. So the argon core fills up all the way through a 1s2, 2s2, 2p6, 3s2, 3p6. So that's my argon core. Now I want to think about just what these 4 valence electrons are doing. These are then going into the 4s and the 3d. So I'm just going to go ahead and draw my 4s part and my 3d. And so I'm going to put my electrons in as 1, 2, 3, 4, using Aufbau and Hund's rules. However, so that one doesn't have any, that one behaves as normal, no special exceptions. However, if I go to chromium, which has 6 valence electrons plus the argon core, when I draw the same orbitals, while you might expect that I would put 2 electrons in the 4s and then 4 of those in the 3d, instead we end up only putting 1 here and 1 in each of the 3ds. And we said that's because the energy difference between the 4s and the 3d is so small that there's actually some extra stabilization associated with having the half-filled shell here that causes one of the 4s electrons to be promoted up to fill the 3d. A similar thing happens for silver later in the table. And then once you get down to the lanthanides and actinides, down into filling f orbitals and stuff, in general you still follow this filling order, but there are all sorts of exceptions associated with those cases. And so then you just have to be careful about making sure that you are, you can use these rules of thumb to get a rough idea of the electron configuration, but you may want to look up in a table to figure out what the true electron configuration is if it's important for whatever you're doing.